WS. My name is Natalio Cortez. I am Director of Training here at Tulsa Welding School at our Houston campus. And today we're going to be covering our 101 welds, which consist of overlapping welds in a flat position, horizontal position, and vertical position. We're also going to move into our T-plates, which consist of our 2F, 3F, and 4F position. But before we get into that, I'd like to cover a little bit about welding itself. So when it comes to welding, just like anything else we do in life, whether it's work, family, we put our love, our passion into it. Welding ain't easy, it's hard, so it's gonna take time and practice for anybody, whether you have no experience, some experience. To this day, I'm still learning something new every day from my fellow instructors, our students. So the learning never stops. And when it comes to welding, I put my love and passion into it. I try my best to make my next weld better than my last weld. Learning, like I said, learning is never gonna stop. Once you complete school, that's just to get your foot in the door. All right, once we get on the field, we're gonna be learning new things, adding on to our toolbox, adding on to our fundamentals that we're gonna get from the schoolhouse, adding something new every day, getting that experience built up, all right, so that it can carry you through your career, your welding career, and pass down your knowledge eventually to somebody else that's trying to come up within the welding field, all right? So having said that, we're gonna move on into some basic fundamentals of welding, and we'll do that next. All right, so now we're gonna move into our machine setup. So going to our machine, we have our ground connection. It's already grounded to my workpiece. We have our positive for our stinger. It's already connected to the positive, which you see the negative and the positive down here, okay? Going up a little bit, we have our positive setting. Our terminals are on, which these are our terminals. Our weld selection, we have it selected to shield metal arc welding, which is the process we're going to be doing today. Okay. Our power right now is off. This is our amperage setting, which we'll get to that here in a little bit. Local and remote. Right now we're set to local, which we're here. And then next I'm going to cover the hot start and the arc control. Hot start is exactly what it sounds like. So if I have my machine set at 80 amps and I have it set all the way to 0, whenever I go to strike my arc, it's going to start off at 90 amps. The more I turn it up, is so that I can get a hotter start. So if I have my amperage set at 80 and my hot start set at 10, my hot start is gonna be about 90 amps. And then once I get my arc established and puddle going, it's gonna bring me back to 90 amps for a smoother and faster start on my weld. For this process, we're gonna leave it at 5. All right, arc control, imagine this as a cone. On the negatives, it opens up that cone, that arc control. The more I go into the positives, it tells you right here, soft and crisp. Like I said, in the negatives, imagine that arc cone opening up to a soft arc. When I turn it into the positives, it's gonna bring that cone more crisp and focus that arc control better for my weld. All right, but for this process, we're gonna leave it also at 0. All right, so now we're gonna turn on our machine and we're gonna start our welding process. All right, now that we've gone over our machine settings, we're ready to start shield metal arc welding. All right, but before we get into that, there are some ABCs that we like to go over. All right, ABCs in welding is always be comfortable. All right, you guys can't see it, but right behind me at the bottom, I have a fan that is off right now. But once I get to welding, I turn that thing on, keeps me cool, keeps me comfortable. All right, and that's the main thing. Body positioning, that's gonna come as you go, but remember the ABCs, always be comfortable. All right, so now that we've covered that, we'll stress a little bit more about the ABCs, but now we're going to get into a few do's and don'ts. So now we're ready to start talking about a few do's and don'ts, all right? Just like I said earlier, building on our fundamentals. These fundamentals that you guys learn in 101, you're going to carry on through each phase while you're here at Tulsa Welding School, all right? And after that, like I said, you're going to keep building on as you go on with your career, all right? So first thing we're going to talk about is the electrode we're going to be using, which is a 7018 Electrode, all right? And we'll cover the information on the Electrode later on, but it is a 3/32 size Electrode, which we're going to be running at 90 amps, all right? So one of the biggest issues that our students have is whenever they come to strike up the Electrode, they either have a hard time striking it, getting the arc built and going, or striking the arc and getting stuck and not knowing what to do after that. All right. A few other issues that our students run into in the very first phase is they drag the Electrode. In other words, once they start the weld, they drag it to the right or to the left if they're left-handed, which in turn causes the weld to be too slim and it's not a proper weld, all right? Some other students go a little bit too slow and make the puddle too wide, too hot, which affects the weld as well. So now I'm gonna show you guys that, how to fix that, the do's and don'ts, so that you guys can have a better start at the 101. So now we're gonna go ahead and get started. We're gonna put our Electrode on the very first edge right here, hold it in place, all right? So the first thing we're gonna do is scratch start. Scratch start is exactly how it sounds, just like a match. I'm gonna do this, scratch it, connecting the tip of that Electrode's metal to my workpiece, which is gonna start our arc. Here we go. All right, so this is a scratch start. Build my puddle, get it to the size that I want, and just let the rod do its job. All right, so now we're going to cover another issue that our students have, which is getting stuck on the workpiece with their Electrode and not knowing what to do. So whenever you go to strike your arc, whether it's a scratch start or a tap start, once you get that going, you will come across some issues where your Electrode gets stuck to the workpiece and it's still connected to your stinger. All right, so now what do you do when you get stuck? All right, and the first thing you're gonna do is pull and twist. So you're gonna have your Electrode on your stinger, you're gonna be welding. Once you get stuck, you're gonna pull and twist at the same time. Pull and twist, all right? Once you get stuck, if you get stuck, pull and twist real quick, all right? If that doesn't work, we're gonna release the Electrode from the stinger. So as you're welding, boom, you get stuck, and you twist and pull, and it doesn't come off. You don't wanna keep going back and forth because the Electrode has 90 amps going through it of electricity, and it's gonna keep getting hotter and hotter and hotter, which is gonna mess up the Electrode. So you wanna let it go, and to let it go, you have the handle on your stinger. You're gonna press that, which opens up your stinger and releases the Electrode. So if you get stuck here, boom, 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 you get stuck, you twist and pull, it doesn't let go. It takes about a half a second to pull off, okay? I'm gonna cover that. And the main thing you guys don't wanna do is if your Electrode gets stuck, and you take off your gloves, go to reach for it to take it off, your hands will be second, third degree burns, all right? So don't do that, all right? So we'll cover that next. So now we're gonna cover, in case your Electrode gets stuck to the workpiece, remember, pull and twist as fast as possible. Okay, here we go. Try to start up my arc, and if my Electrode gets stuck, like this, I'm gonna pull and twist. Pull, twist. One more time. Get stuck. Pull and twist. All right? If that doesn't work, and I got my weld going, and all of a sudden it gets stuck again, like this, this and I twist and pull and it doesn't come off, I quickly want to come to my stinger on my handle right here, and about a half a second, squeeze and pull. All right, now we've covered how to, if your electrode gets stuck to the workpiece and you pull and twist, or you can quickly let go of your electrode by squeezing the handle and letting it go with a split second. All right, but you will get nervous, you will get in the moment, and if you don't know what to do, your mind goes blank, I'm gonna show you guys what could happen to your electrode if left stuck on the workpiece. Here we go. All right, right now, my electrode is stuck to my workpiece, okay? The electricity, the 90 amps, is coming through my stinger and into my electrode. You guys see that getting hotter and hotter? The 90 amps are still going. My electrode is still hot. And look, I'm not putting no force into it, and it's turning bright red, and that is very, very dangerous. All right, so now that we covered what to do in case your electrode gets stuck on the workpiece, now we're gonna talk about the importance of travel speed, all right? And one of the main things that I ask our 101 students is, how do you know how fast to go, all right? And the puddle is key. The puddle tells you how fast you need to go, the angles that you need to be working, but some of the issues that our students come across is dragging the electrode or waiting too long in the puddle, making it wide, too wide, and not a proper weld. So when I say dragging, my angle, like I said, ABCs, always be comfortable. So my body positioning is very important. I'm gonna post up my elbow on my arm here. I got my work table. My electrode, I'm gonna have at about a 30-degree angle. And whenever I start welding, all I'm gonna do as the welder is build my puddle and let the electrode burn right in front of that puddle, and slowly let the electrode burn down into that puddle, carry me from point A to point B, all the way down consistently. All right, that's what I want to do. But a few students come in and they drag. What I mean by drag is once they get their electrode started, they go from left to right with their body. And that's what you don't want to do. That's dragging, all right? And that'll make your weld, you're not gonna build a puddle, you're just gonna be dragging the electrode, not making any type of weld. Another issue is where the students bring the electrode work angle a little too high, and instead of letting the electrode burn down and carry them, they stay in that same spot a little too long, which makes that puddle a little too wide and gets a little out of control. All right, so we're gonna cover that next. So here we go. We're gonna do a proper weld. We're gonna scratch start, build our puddle, get it to the size that we like or needs to be. And our job as the welder is to keep that puddle the same width, the same length, all the way across. And like I said, all you gotta do is keep this tip of that electrode right in front of that puddle and let the electrode burn down into that puddle. And with your work angle, which is at about a 35 degree angle, is gonna let your electrode burn down. And as the welder, all you're doing is guiding it down. All right, so we're gonna do that next. Here we go. Scratch start, build my puddle to the size that I like. I like that size right there. Keep that tip of that electrode right at the front edge of the puddle. And as the welder, I'm just guiding the tip of that electrode, keeping it right in front of that puddle. My eyes are going back and forth from my puddle to the right side to make sure that I'm staying as straight as possible, putting that weld where it needs to be. And all I'm doing is letting that electrode burn down, and I'm just guiding it down. All right, so now that we laid our first weld down, to clean it off, we have our chipping hammer. and our wire brush. All right, now what you don't want to do is chip away at your weld with either the sharp tip or the knife edge tip. All right, what you want to do is get your sharp tip, and if you don't have a clamp, use your wire brush to hold your workpiece down, and all you want to do is with that sharp tip, scratch on one side of the weld, either side. The harder stuff that doesn't want to come off, that stuff you can chip away at carefully. All right, once you get all that slag off, switch off. All right, so now you want to use your chipping hammer, if you don't have a clamp, to hold your workpiece down. Take all that slag off and brush. All right, now you have a clean work surface to continue your welds. So now another issue we're going to go over, we already did the proper weld, so now we're going to do a weld going too fast or dragging it. All right, here we go. Scratch start. I got my puddle going, but I don't pay attention to that because I'm moving my body from left to right. Y'all see that? I'm still having my weld, but I don't have a puddle. I'm just moving my body left to right, and I'm dragging it. I'm going way too fast. So we just finished running a weld. We ran a proper weld and a dragging weld, which is too fast. Even cleaning it up makes the weld more difficult to clean off. With the chipping hammer, if I try to knock off that slag, because I went too fast, it's going to be that much harder to chip away at the slag. You see that? So now, in this case, now I'm going to have to chip at it, which I don't want to do because that'll might add a defect to my weld. All right? So I'm going to use my wire brush to help me clean this off, or my wire wheel. And now you guys can see the difference in both welds. This is the proper weld right here. I have my puddle built right there, and that's exactly how I wanted it. Right here, I see what might be a puddle, but that's not a consistent build puddle. Right here, I used a scratch start. I tried to build my puddle, but like I said, I was moving my body. I don't want to move my body. If you move your body, this is the result that you'll get. What you want to do with the proper weld is have that proper work angle and just let the electrode burn down, and as a welder, you're guiding the electrode down as it melts. All right? So now what we're going to cover is having another bad angle, which you're a little too high. You start up the puddle, and you stay a little bit too long, making that puddle a little too wide and out of control. Right. So now we have a proper weld, a dragging weld, which is a too fast weld, going too fast, and now we're going to cover a going too slow weld. Here we go. So I build my puddle, but I don't have a proper work angle, so my puddle is getting too wide, too hot, out of control, and that's not what I want. I'm still keeping the tip on my electrode right at the very front of the puddle, but I'm not really moving anywhere. All right, so now we've laid down a proper weld, a dragging weld, which is too fast, and this is going way too slow. All right, same thing, either have a C-clamp or a wire brush, get the chipping hammer, go to the edge of the weld, try to chip it off, scratch it off. If it doesn't come off, gently tap on it, switch it over. Switch over, brush it off. All right, and now you guys can see, like I said, the proper weld, too fast weld, and this is way too wide, too slow, making your puddle a little too hot, that could easily get out of control. So now another issue we come across with our students is not knowing the arc length. Right, the arc length is from the tip of your electrode to the workpiece. So once you strike up, you have to be a certain distance away from your workpiece. All right, right here, I'm touching my workpiece. I don't want to touch my workpiece as I'm welding. I want to have lifted up just a little bit, which is about a 1/16 to 1/8 away from my workpiece. If I go too much, if I spread my electrode away from the workpiece too far, that's going to be long arcing. Long arcing, I lose my puddle, splatter goes everywhere, and I lose my direction, I lose everything. All right, so you do have to have a proper work angle and the proper arc length. You can't really measure it by looking at it. With experience, that'll come. But as you're welding, all you want to do is keep that tip of that electrode right at the tip of that metal. And like I said, slowly let the electrode burn down into that puddle. And you as a welder, you're just guiding that puddle and keeping that puddle satisfied, burning the electrode at the very edge of that puddle, not going too close to the workpiece or not going too far from the workpiece. And we'll cover that next. We're going to demonstrate what long arc looks like, what it does, and what short arc is and what it does. First, we're going to start off with long arc. Here we go. Strike up. So I got my puddle built. I got it the width, the length that I like. But now my electrode, notice as I bring it up, it's going to get brighter and much more spatter is going to come up. Y'all see that? My arc is, I'm losing my puddle. My arc is going everywhere. And if I go too high, it's eventually going to shut off. And now we're going to cover, we just covered long arc. Now we're going to see what too close to the workpiece looks like. I get my puddle built how I like. I have about a 1/16 to an 1/8 arc length. Now watch what happens if I get too close to my workpiece. It's going to get a little darker. It's going to be a little bit harder to see my puddle. Y'all see that? I'm nearly dragging my electrode into that workpiece. So now if you guys come over here, this weld right here, we started it off. We had a good arc length going. And then about right here, I started to go a little too high. And a few times I lost my arc. I had to come back down, restrike. And I went a little too far again, lost my puddle, lost my arc, and eventually disconnected from the workpiece. And this is the end result of that. On this weld here, I started my arc, and about right here, I started pushing my electrode too close to the workpiece to where I was nearly touching it, and that's being too close. And right here, I lost my puddle. It got a little darker around me, harder to see where I'm going. It doesn't look too bad of a weld, but if you're having trouble seeing, that might be one of the causes, one of the reasons. So another issue our students come into is the electrode. This is a used electrode. And if you guys look closely, you can see the metal at the tip of the electrode. Now what you want to do whenever you're welding any electrode, you want to burn it all the way down to the numbers. If your electrode gets stuck and it gets damaged, it's still usable as long as it has the flux all the way around it. Okay, so now I'm going to show you guys what to do in case your electrode gets stuck or you finish a weld and you still have about a half a weld to go, and how to keep using that same electrode. I want to show you guys the difference. This is a perfectly good electrode, both of these. This is half used, this is a full electrode. I started to weld with this new electrode and I stopped real quick to show you guys what happens with the flux at the tip of the electrode. Right here, you have a little bit of metal showing on that electrode. Right here, you have the flux covering the tip of that electrode. If I put this electrode on my stinger, I'm gonna have an arc right away. But I'm gonna need to burn the metal that's showing off first, and then get into the flux, and then start my puddle, and then start my weld. With this one, if I put this electrode in my stinger, I go to strike an arc, that flux is covering the metal, so I am not going to be able to get metal-to-metal contact, and that's not going to allow me to start my puddle and get my weld going. A few ways you can get these two electrodes to continue to work. With this one, you can either use the tap method, trying to break through that flux to where you have clear metal. So now you have clear metal on both electrodes. If that still doesn't work, we have our file. We have a flat edge, a round edge. We're gonna use our flat edge and put our electrode with flux on it, scratch it a few times. And that gives us shiny metal, and again, putting metal to metal contact so you can start up your arc. So now that we've covered the do's and don'ts in Welding 101, there's still a lot more to learn, okay? A lot more knowledge is gonna come. The more knowledge you get, add that to your toolbox, keep adding to those fundamentals. Now moving into our workpiece. Our workpiece, you want bright, clean, shiny metal. You have your wire brush here. All right, this, you want to use your wire brush, put pressure on it, go back and forth. And this wire brush with some slight pressure will give you the bright, shiny metal to have a clean, smooth working surface. Now we're ready to weld. A lot of our students like to use a guide to guide them to keep as straight as possible. And for that, we have our soapstone here. You don't need a ruler or anything. Just put a flat plate, give you a solid mark. And now that we have our guide established for our first weld, now our body positioning comes into play. So let me explain our body positioning and our work angle. So I have my arm here, which I'm gonna place my elbow on. My work angle is gonna be at about a 30-degree work angle, and I'm gonna bring it down about 5 to 10 degrees. The reason for that, as I'm looking at my electrode and my workpiece, my eyes are gonna be bouncing back and forth from my puddle to the right side to keep me on track. So as I'm welding, my electrode is gonna be slowly going into that puddle. My eyes are gonna be, like I said, bouncing from left to right. I wanna be looking over my electrode to see my guideline, but I wanna keep my eyes going back and forth to my puddle so that I'm making sure that that puddle is staying consistent all the way down. Now we have our workpiece cleaned up, looking like bright, shiny metal. We have our guideline to help us guide and stay as straight as possible. I'm gonna go ahead and run the first weld. Use the scratch start, build my puddle. My eyes are looking to the right to make sure that I'm staying right on that white chalk, but they're also bouncing to the left to make sure that my puddle is staying consistent as possible. My arc length, I'm watching my arc length. If I start to lose my puddle, I might be too high or too low. So I have to keep an eye on that as well. Staying at the front edge of that puddle all the way down. We just ran our first weld. Gonna grab our chipping hammer and wire brush, knock off the slag, A lot of welders love it when this happens. What this means, if the slag starts to come off by itself, it means that you have the right speed, the right arc length, all the way down your weld. Okay, holding down the workpiece, going on this edge, knocking off the flux. Switch over, hold it down with the wire brush. Our next weld is going to be on the top side of this weld. So as I'm looking at my weld, I have a bottom edge, a top edge. Each weld has a left, right, top, bottom edge. In order to get the perfect overlap that we're looking for, is simple. Keep that tip of that electrode right on that edge of that previous weld. Before, we had a chalk as a guideline, which gave us our straight first weld. Now, we're going to use the top edge of this weld as a guideline to keep us straight as well. This weld, I'm going to stop about 1 inch short as I move on with each weld so you guys can see the progression and what the overlap looks like. Starting off with our second weld to get our first overlap. Build my puddle. Look to the right to make sure that I'm staying right on that edge of that previous weld. My eyes are still bouncing to the left and to the right. To the left to make sure that my puddle is staying consistent. To the right to make sure that I'm staying as straight as possible, staying on that edge. Staying on that edge will also give you the proper overlap we're looking for. Keeping that tip of that electrode right at the front of the puddle. Just laid our second weld down. We're going to use the wire brush or C-clamp to hold our workpiece down. Same thing, going right on that edge of that weld to knock off the slag. So now talking about the overlap. Again, all I did with my electrode was keep the tip of that electrode right on that top edge of this first weld. My puddles, if you look at my puddles here at the end of the weld, are about the same width and length. And by keeping that tip of that electrode on that top edge, that gives me the 50-50 overlap all the way down across my weld. Now we're going to get ready to run a few more welds to show a little bit more progression. Starting our third weld, scratch start. Build my puddle. Keeping my eyes moving to the right side and to the left. On the right side, making sure I'm staying right on that top edge of the previous weld. Looking to the left to my puddle to make sure that I'm keeping as consistent as possible. Guiding my electrode down. Keeping that arc length about a 1/16 to 1/8 off my workpiece. Our fourth bead, scratch start. Build my puddle. Get it to the width and length that I like. Keeping my eyes to the right to make sure that I'm staying as straight as possible on that top edge of the previous weld. Looking at my arc length, making sure I'm staying about a 1/16 to 1/8 off. Letting that electrode burn right in front of that edge. Scratch start. Build our puddle. Keeping my eyes moving from the right side to making sure I'm staying right on top of that edge. Looking to the left, ensuring that my puddle is staying the same. Now that we've laid down about 5 overlapping welds, if you guys come in close, you can see the overlapping about 50% from that first weld to the second, third, fourth, and fifth. If you look at the end of each weld, each puddle, it's about the same width and the same length. On all the welds, I kept the tip on my electrode right on this top edge of every weld. Except for this first weld, we'll use a chalk line to keep it straight as possible. After that, just staying on the top edge of the previous weld, keeping that puddle consistently the same width, the same length, and watching your arc length. If you watch all those steps, you'll get this perfect overlap, which is about 50% on each weld, covering 50% of the previous weld. Now we're moving on to our horizontal welds. In order to move on to our horizontal welds, we're not going to be able to use our C-clamps or anything to hold our workpiece in place. So what we got to do is tack it into place. How do you want to tack it? I always tell my students, you want to be facing your workpiece about 1 foot to 2 feet from your workpiece, and you want to face it towards you. In school, you have an option to get your workpiece the way you want it, the way you like it. Once we get out in the field, all that's going to change. We're going to get into restricted welds where we can barely stick our hand into that weld and make that weld. We can barely see. Sometimes you'll be using a mirror to weld on the back of a pipe or plate. All right, but what we're learning, we can adjust it to the way that makes it easier for us. So a tack is the same thing as a weld. We're putting 2 pieces of metal together with enough strength to hold it in place for what we need to. So all I'm gonna do is with my electrode, I'm gonna strike up right here, and same thing, build my puddle. Once I get my puddle built on both my top workpiece and my table, I'm gonna do the same thing. Keep that tip of that electrode right at the front edge of that puddle and keep my puddle the same width and length to give me a proper tack, which should be about 1/4 inch to 1/2 inch. Tacking the plate up, scratch start, build my puddle. Now my workpiece is tacked and ready to go. Now moving into our horizontal weld, I already have my chalk line right here to keep me straight as possible. On my stinger, you have the option to put it on that very first groove right here, or you also have this 45 where you can put it, clamp it down to keep your electrode in place. All right, and that's what I'm gonna use for this weld here. Talking about the ABCs, always be comfortable. Body positioning matters. When you guys get out in the field and get more experience, you're gonna be welding with one hand. All right, just propping up, making your weld. But as you're starting off, you wanna have about 3 points of contact. 3 points of contact, one being your elbow or shoulder. You definitely don't want to put too much weight on here. You're just using this just in case to keep you as straight as possible, as steady as possible. And you don't want to put too much weight on here, whether it's your elbow or shoulder. You want to keep it light so that if you have to move, you can move back, up, down, forward to readjust your body. Your feet matter, the placement of your feet. So if I'm just here like this with my feet touching each other, this can get me off balance. All right, so what I want to do is be about 1.5 to 2 feet away from a workpiece, put my elbow up, and move your feet around. Put your front foot or right foot forward. If that doesn't feel good, switch your feet. The whole point is for you to be comfortable. And what I like to tell my students is to do a dry run. A dry run, it just allows you to get from point A to point B with nothing being in the way. So I tell my students to start off where they're gonna end up at. So I wanna end up here. So I wanna get comfortable here. Once I'm comfortable here and I have my work angle the way that I want it, I want to come back. The way that I'm holding my stinger, I got my handle right here. The other hand, I'm barely touching my fingers, my stinger, the bottom of my hand, the bottom of my stinger, just to help me keep it steady, as steady as possible. Once I'm comfortable here, I want to come back and do a dry run. A dry run, like I said, is to make sure you can get from point A to point B. And same thing as the flat position. Once I start my weld, you want to have a work angle about 10. Right here I'm straight. I want to have about 10-degree angle, and I want to come down about 5 degrees so that as I'm welding, I'm looking to the right side to make sure that I'm staying as straight as possible all the way down my weld. My eyes have to be able to look on the right side, look on the left side, so that I can keep that puddle consistent. Like I said, my work angle, this is straight. I'm going to come down about 5, over about 5 or so that it gives me the visibility that I need to put that weld down. Build my puddle. Looking to the right side, making sure I'm staying right on that chalk. Also keeping my eyes to the left to ensure that I'm keeping my puddle the same width, the same length, all the way down my weld. Also keeping a close eye on my arc length, making sure that I'm not touching the metal or I'm not going too far away from the metal. All I'm doing is pushing forward. Just ran our first weld. We had our chalk line here that helped guide us to stay straight. Same thing as the flat. Now we're going to use the top edge of this weld to keep as straight as possible. Again, I'm going to cover the work angle right here straight into the workpiece. I'm going to bring it down about 5 degrees or so, over about 5 degrees or so. This allows me to see over my electrode to the right side to make sure that I'm staying as straight as possible on that top edge, but I'm also bouncing my eyes to the left to ensure that I'm keeping that puddle consistent all the way down to my weld. Now we're going to get ready to run our second weld on top of this first one. I have my first weld down already, and for every weld I want to do a dry run. So I want to start where I want to end up at, come back, ABCs, always be comfortable. Looking to the right side to make sure that I'm able to see the top edge of the previous weld. I'm not using no motion at all. It looks like I'm moving a little bit, but it's just me shaking, trying to keep the electrode as steady as possible. Pushing forward. I'm not moving my body from left to right. I'm simply letting the electrode do its job. As the welder, I'm just guiding it across. We just lay down our second weld, do a dry run for my third weld. I'm good. Build my puddle. All I'm doing is pushing forward. That work angle that I have allows my electrode to burn with me pushing it forward and keeping the tip of that electrode at the front edge of that puddle gives me that perfect overlap we're looking for. I'm looking over my electrode to the right side. Our fourth weld, dry run, feel comfortable. scratch start. You're gonna run into this issue. Remember, we have our scratch start right here, which is not working for us. One thing we can do is tap to try and break through that flux. Once we break through that flux, we have an arc because it's metal to metal now. Build our puddle. Keep our eyes bouncing from left to right. On the right side, ensuring we're staying right on that top edge of the previous weld. Looking to the left side to ensure that our puddle is staying as consistent as possible. Pushing forward on the electrode. Going into our 5th weld, dry run, scratch start. Build our puddle. Watching my arc length as I push forward on the electrode. Now we've completed our horizontal welds. If you look at it, this was our first weld, which we had our chalk line to help guide us to stay as straight as possible. After that, for each weld following after that, all I simply did was keep the tip of that electrode right on that top edge. If you look at both or all of the end of the puddles, they're all about the same width and length, allowing me to, or giving me the 50-50 overlap that we're looking for. Another thing I want to cover on this horizontal weld, with a lot of our students, the issue that we're coming across is body positioning. They put too much weight into the workpiece, which locks them into place, now allowing them to continue to push forward. So then they start moving their body, trying to move their body, but they're stuck. So the end result of that, instead of having a straight weld, once they get to about the halfway point, about 3/4 of the way, the weld goes from straight and starts to drop off. Because a lot of students get to about halfway point and they run into an issue where they have too much weight on something or they're not comfortable, and now all they can do is move their body to the right or left, which in turn drops their weld. So it's very important not to drag your welds or move your body. All you simply want to do is, with your electrode, as long as you have that 5 degrees down, 5 degrees over, at that work angle, all you should have to do is push forward. And keeping that tip of that electrode right on that edge. With that work angle, all I'm doing is pushing forward. I'm not moving to the right side. That work angle allows the electrode to burn into the puddle, into the weld, and by itself it's moving to the right as long as I keep that puddle consistent all the way down. That's why it's very important to do dry runs, so that you want to end up here, so you want to get ready here. Get comfortable. Once you're comfortable, come back to where you're actually going to start, and you're able to see over your electrode to keep you straight as possible. And from here, all I'm doing as the welder is pushing the electrode forward. And I'm just guiding that electrode as it melts into the puddle. Watching my arc length and looking to the left and to the right. Now we're moving on to our vertical welds. I already have my coupon, my plate tacked up to my table here. I have my chalk line to keep my weld as straight as possible. On my stinger, same work angle. I have it at that 45 degree, clamped on tight. ABCs, always be comfortable. Same thing, later on in you guys' career, they're gonna be able to weld vertically, horizontally, flat, around the pipe with one hand, left hand, right hand. But right here in the schoolhouse, where we're learning, 3 points of contact, elbow or shoulder. Make sure your feet are how you like to be comfortable. Making sure you do the dry runs. I want to end up right here, so I'm going to start by getting comfortable where I want to end up at. Come back where I'm really going to start at. Make sure that nothing is in my way. Make sure that my body positioning is as comfortable as possible. Once I strike up my weld, that work angle that I have right here, that 45 degree angle, same thing. I'm not going to be pushing my electrode up. I'm not going to be forcing to speed my weld up. All I'm going to be doing is pushing forward. Just like that. So on this chalk line here, if I strike up, build my puddle, once I build my puddle, I'm going to have a harder time looking at my puddle underneath my electrode. So what you want to do is get as comfortable as possible, and on your puddle, you're going to be able to see the top side of your puddle, which is like a half a moon on the very top. If you're keeping that as consistent as possible, the bottom of the weld is perfectly fine. So just keep that in mind. Whenever you're welding vertical, you're not going to see your full puddle because your electrode is going to be in the way of your visibility. So just keep an eye on the top part of the puddle, ensuring that you have that half moon shape. And if you have that on the top, carry that up, continuously pushing forward and not moving up. So we'll do that next. Now we're starting our first vertical weld, do a dry run. This is where I want to end up at. Start from there, come back, make sure I clear my workpiece, come down to where I'm going to start at. Scratch start, build my puddle, and I'm just looking at the top of my puddle, ensuring that I have that, I see that half moon shape at the top of my electrode. And all I'm doing is pushing forward. I can't really see the bottom of my puddle, but if I see the half moon shape on the top of my puddle, the rest of my weld is following me along perfectly fine. Now here you're going to have a hard time noticing the arc length. But like I said, all you got to do is keep pushing forward. We just put down our first weld, vertical weld. And let me turn my electrode around so you guys can get a better view of what I'm talking about. So I had the tip on my electrode right here. The half moon shape is right here. So as I'm pushing forward into my puddle, I'm keeping an eye on this half moon shape at the top of my puddle. If I see that continuously all the way up, that means that the bottom of my puddle is following me along just fine. And now that we've ran our first weld and we don't have a chalk line no more, now we're going to use this right edge of this first weld to give us that overlap we're looking for. Build my puddle, looking at that right side edge of the previous weld, staying right alongside it. Trying to keep that half moon shape at the top of my puddle, continuously going up and continuously pushing forward on my electrode. I'm not worried about the bottom of my puddle. We just finished running our second weld. This was our first weld here on the left. This is our second weld. One thing I forgot to mention earlier, I have my amperage set at 90 amps, which is working perfectly fine for me. On our first weld, we had the chalk line. On the second weld, we used that right side edge to keep us going. On this last weld, like I said, I'm not really paying attention to the bottom weld. I might get a glimpse of it every split second here and there, which is fine, but the main thing I want to focus on is that the top of that puddle, keeping that half moon shape all the way up. And like I said, all I'm doing is pushing forward. See, all I'm doing is pushing forward, and my electrode is moving up on its own. I'm not going up with it. I'm pushing forward. And that work angle alone moves me up as I need to. So now we're gonna run the rest of our vertical welds. All right, do a dry run, comfortable, scratch start. Build my puddle. No motion at all. I'm just pushing forward. Keeping an eye on the top edge of my puddle. Build my puddle, start pushing forward. Again, I'm not using no motion. If it looks like I'm moving, I'm just trying to keep the electrode as straight as possible. Trying to keep the top of my puddle, keeping that half moon shape. If I see that, I know that my bottom puddle is following me along just fine. Our fifth weld, dry run, scratch start, build my puddle, start pushing forward. So this concludes our Intro to 101 with our overlapping welds. All right, we did a 1F, which is our flat welds, 2F, which is our horizontal welds, and the 3F, which is our vertical welds. And this is the end result. So right here we have our 1F, which was our flat welds. We did a total of 5. We moved on to our 2F, which is our horizontal welds from left to right. And we finished off with our 3F, which is our vertical welds. Hope you guys enjoyed it. Got something out of it. It was a pleasure throwing down some welds. Please like the video, make some comments on it. You know, if you guys want to see something else that I might have not covered or mentioned, by all means, add it onto the comments. We'll gladly come back out here and answer those comments or questions you guys have at the bottom of those comments. Again, my name is Natalio Cortez, Director of Training here at Tulsa Welding School at our Houston campus. Till next time, thank you.